All right, so what are the key takeaways from this lesson? Well, let's recap some of our new rules that we found, starting with the idea that the derivative of a constant is 0. And to apply our notation to that, the derivative of a constant is 0. This statement and this statement say the exact same thing. The derivative of a constant is always going to be 0. If I'm taking the derivative of a constant multiple times a function, that derivative, so a constant multiple or a coefficient as you'll probably refer to it, times a function is simply the constant times the derivative of the function. Or to apply our notation to that, if I take the derivative of a constant times a function, it is equal to the constant times the derivative of the function f prime of x. And you saw with some coefficients that that's actually a pretty easy thing to take the derivative of. The other rule that we applied here was the derivative of a sum or difference is the sum or difference of the derivatives. And to apply our notation to that statement right there, if I take the derivative with respect to x of the sum or difference of two functions, it is equal to the sum or difference of the derivatives. It's equal to f prime of x plus or minus g prime of x. And that's really the rule that allows us to take a polynomial and split it up and take the derivative of each individual piece that's separated by a plus sign or a minus sign. And as we saw in the previous video, if it's not written as a polynomial function, sometimes a function can be rewritten as a polynomial, either by multiplying it all out or taking a fraction with a single term in the denominator and expanding it out. But a lot of times we can take a function that's not in polynomial form and rewrite it as a polynomial to easily take its derivative. And that's going to be something that's actually a very common skill. This is going to be a really important skill for you to be able to master. It's going to be very important that you be able to use these rules to take the derivatives because we're going to be taking the derivatives not just here in Unit 2, but also in Units 3, 4, and 5. And it's going to be something we're going to need to verify what we do even beyond then. So going to be really important that if you look at 2.5 and 2.6, pretty simple rules, pretty easy to apply rules, but they really are critical that you understand them in order to take derivatives moving forward.